Okay, so hopefully you have already looked at the transformations part 1 video where we did the front of the notes and a little bit of the back. We're going to go back and use Desmos now that I've got my screen recorded. And we are going to just look at a couple of things really quick to make sure we understand how to use Desmos. So remember that quadratic functions can be written in standard form or vertex form. If we've got a standard form, we look at that c value, that constant, just that number, and we can find the y-intercept. Vertex form, we can find the vertex by the formula. We've got HK, and that gives us the vertex, and we can also find that using Desmos. So if we look at this first example, we know that it's in vertex form. We've got those parentheses, and so if we type in the -2 x plus 7 squared plus 8, we've got a vertex, we've got a parabola over there, and we find that my vertex is -7, 8. So you can find that on Desmos by graphing it, and you can also use your formula. Standard form, if we use that second example, so 5x squared minus 6x minus 2, we've got another parabola, and we can find the vertex, but it's not as easy. And then the main thing we really want to worry about is finding that y-intercept, so where it crosses the y-axis, and we do find 0, -2. And we could have figured that out without graphing it, but I just wanted to show you the Desmos as well. If we look at this bottom part where we talked about the transformations, that's a really good thing to know. If we start with our most basic function, which is x squared, it's the parabola, it's the parent function, it crosses at the origin, it's a minimum, we got all these things about it. If we compare that regular x squared function to anything that has been transformed, and we compare their graphs, so 3x plus 1 squared plus 1. We see if we're comparing their vertexes, we go from 0, 0 to -1, 1. So we know that we go to the left a little bit and we go up a little bit. So we know exactly we go left 1, up 1. We can also see that it opens a little bit narrower. So the purple graph is my original graph, my x squared, and the black graph is my transformed function, and we see that its opening is much smaller. So that takes into account the vertical stretch. We'll look at one more. We'll look at this example 6 down here. So we've got -2 x minus 7 squared plus 10. And so what happens there is, I'm going to zoom out just a little bit, we see that my graph flips over, so we've got a reflection over the x-axis, thanks to that negative in front. We also see that my vertex is going from the origin over to the right, 7 units. And we also see that it is up. So it has moved from that very origin, that center, all the way into quadrant 1. And so we go to the right 7 and up 10. We can also see maybe a little bit that it has, the opening is a little bit narrower, so it has that vertical stretch. Stretches and compressions are a little bit trickier to see, so that's where we really want to take note of that a value. Is it greater than 1 or is it a fraction? So if you'll flip to the back, we know that we can be given the transformation functions and we can write functions with the transformations in vertex form and convert them to standard form. I did mention in the previous video that if you've got your vertex form and your standard form, you can check to make sure that they are the same by graphing them both. So if we write our vertex form, graph it into Desmos, x minus 4 squared minus 1, and then after we did all that algebra, we found 2x squared minus 16x plus 31. When you graph them, you should only end up seeing one graph. And so that means that they are graphed on top of each other, and so they are the same, they are equivalent. So when you get multiple choice questions that say which equation is equivalent to 2x minus 4 squared minus 1, what you can do is just compare their graphs. If they're exactly the same, you know that they are equivalent to each other. So we are going to go ahead and finish the rest of the notes. We're going to rewrite each of the following quadratic equations from standard form into vertex form, so we're working the opposite direction. All we're going to do, we're going to rely heavily on Desmos. It's a great resource. We are going to type in our original function into Desmos and find our vertex. So if I type in x squared minus 8x minus 5, make sure that you're comfortable typing it into Desmos. We find that my vertex is 4, -21. My a value is the leading coefficient. So x squared has a 1 in front of it, so my a value is 1. That tells me that it's a minimum. That tells me that it has not been stretched or compressed. And once we've got the vertex, all we're going to do is write it in this form. So a times x minus h squared plus k. Remember, h is always the opposite sign, k stays the same. So we'll have y equals, my a value is 1. If it helps you, you can write it. If you know that it doesn't need to be there, you don't have to write it. So we've got x minus 4 squared minus 21, and you can, of course, check it by typing it into Desmos and making sure that your graphs are the same. And they are, we're good to go. If we look at this second example, we'll start off the same way. We'll type it into Desmos and find our vertex. So my vertex is way up here, 357. And from our original equation, we find that our a value is -4. So when we write the vertex form, we'll start out with the a value, which is -4, parentheses x opposite h squared plus 57, k stays the same. And you do want to make sure that it is the same, so we'll type in that equation into Desmos. It's always good to check yourself just in case you make a simple error that can be fixed. They do graph the same. They're exactly on top of each other. No extra parabolas anywhere on that graph. Good to go. So we'll look at this third one. We'll go ahead and find our a value before we type it in. The a is in front of x squared, so my a value is 1/3. We will find our vertex, so 1/3 x squared minus 4x plus 10. We find that our vertex is 6, -2. And so when we write it in vertex form, we'll start off with our a value. We'll have x opposite h squared minus 2. And of course, you can check yourself. 6 squared minus 2. And they do map on top of each other. All right, last thing we want to do is if we've got vertex form, so if we're going from standard to vertex, we can go one step further and identify their transformations. So we're going to do that in the last two. So go ahead and pause the video, see if you can write number 13 in vertex form. So first things first, I'm going to type it into Desmos, find my vertex. Vertex is 611, so when I write it in vertex form, taking into account that a value, that's a -1, I've got x minus 6 squared plus 11. And when I do that, once I've got vertex form, I can easily identify the transformations. That negative in front tells me a reflection over the x-axis. That -6 inside the parentheses tells me I'm going to the right 6 units and up 11 units because of that plus 11 outside. And of course, to figure out those transformations, you can always compare it to your parent function. So we see that it does indeed move to the right and up. All right, last one, go ahead and find your vertex and write it in vertex form. Pause the video, work ahead of me. All right, I've got it graphed here. I find that my vertex is -8, -15. When I write it in vertex form, I want to make sure to use that original a value. So I've got 1/2 x plus 8, so opposite h, minus 15. All right, and when I do that, my transformations, I've got a vertical compression. We see in our graph that it opens pretty wide. We see that my vertex, moving from the origin, it goes to the left 8. and down 15 units. Once you've got all your transformations and you're pretty comfortable with Desmos, you may begin to work on your homework.